It started out with graphene and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3.
Alright, here is the introductory video for B0. And radicals, again, is this symbol. That's a radical. And if you don't have a number inside the radical, this part is called the index. If there's no number there, it's a 2. Inside here, this is called the radican. Just some technical names. Okay, so, but for our purposes, we're not going to have a 2 here. We're going to do a cube root. So a cube is 3-dimensional, right? It has length, width, and height. And so that number is actually going to be a 3. Okay, so we're just going to go ahead and graph the cube root. Okay, so I have y equals the cube root of x. And let's go ahead and just graph this. If I put the value of x, let's just say I put in 0, and I put it in here, okay? Essentially that would be 3 identical numbers that multiply to be 0. Well, that would just be 0. Okay, so let's try it with a different one. Let's try -1. Now, if I put in -1 there, I'm trying to think of 3 identical numbers that multiply to be -1, and that would actually be -1. So the cube root of -1 is going to be -1. Okay, let's try -2. The cube root of -2, the answer is take that back. If I take, let's do this way. If I put in -8, that's what I was supposed to write, -8. This would be -2 to the 3rd power, right? So -2 times -2 times -2 would be -8. So this would give us a -2. This would give us a -1. This would give us a 0. Okay, let's try positive numbers now. Let's just say I pick a number. If I pick 1, this would be, right, that would just be a 1. My output would be a 1. Now if I chose, again, you have to think of cube root of 8. This would be 2 times 2 times 2, or 2 to the 3rd power. And those 3's would cancel there, and you're left with just 2. So if I put in 8, I get 2. Okay, this box right here is really important because these are our reference points for a cube root. Okay, so let's go ahead and graph those really quickly, and then you can see the graph. -8, -2, -1, -1, 0, 0, 1, 1, right 8, up 2. Okay, so this is a graph of my function. And we learned back and in your previous problems that basically this is the inverse of x to the third power. This is the inverse of x to the third power. That's why actually it looks like a cubic function. It was basically just cubic function was this way. And basically all we did was just rotate it 90 degrees counterclockwise, and then we reflect over the y-axis, and that's how you get the green one. Okay? So, what about our transformations of cube roots? Well, more importantly, I'm going to put this number in there. And you still have the same thing. Using f of x equals a times the cube root of b times x minus c plus d, the question is the number, so the number that we're talking about is the b, is it inside the radical? Well, the only two letters that are inside are b and c. Okay, c is our horizontal translation, and b is going to tell us if it's going to reflect over the y-axis or our horizontal dilation, compression. Okay, so notice how it's inside the radical sign. Or, that was A, and B, it might be outside the radical sign, like the A and the B are. A and D are here. Do you see that? And if it's to the left, if there's a number to the left, that's your A value. If it's to the right, that's your D value. The A and the D affect the Y coordinates. Okay? So you can either take words to the letters A, B, C, and D, or find out numbers to A, B, C, and D, and then transpose it to some characteristics. And if you ever need to move the order pairs, you can. All right, so we've already gone through characteristics and the square root, and it's essentially the same thing. So let's just go over those. Your A value is talking about verticals. You can call this stretch. So if your A value is less than 0, it's going to reflect over the x-axis. And basically it's a stretch or compression. The absolute value of A. So let's go to B now. Notice how B is on the inside, and that B value is the horizontal stretch or compression. And if this number is less than 0, it's going to reflect over the y-axis. And then the factor, they call it, is the absolute value of 1 over b. All right, let's do the c value. This is our horizontal translation. And if this value is greater than 0, it's going to go towards the right. And if c is less than 0, you actually go to the left. And remember my silly phrase, add to x, go west or left. And then the last one is your d value. This is your vertical translation. And if your d value is greater than 0, it's going to move up. And if it's less than 0 or negative, or something smaller than 0 is a negative number, it's going to go down. And that is specifically the cube root. All right, B1, the directions tell us to sketch, so we're going to make a sketch of a graph of the f of x equals the cube root of x as described in the exercise. And then number 2, we have to write an equation to describe each of the new functions. And then basically, they already have shown us on the graph, this is the parent graph. Right? You are the child, you look like your parents. I look like my parents. All right, you just copied the introductory video in there. Let's look at beat number 1. So the first thing I'm going to do is probably write an equation and then we can graph it. So how do I take these words, translate the graph to the right 1 unit? Okay, so which letter is this? Go ahead and write it out. And the D is on the outside. Okay, which one do we not need here? Well, this is a C value. And this is a C value of 1. Going to the right 1 unit. So I don't need A, B, and D. So now I just have f of x equals the cube root of x. Now I'm going to put this one here. And we're trying to get c equals 1. So that's what I'm putting right there. And then we don't need the d value. Okay, so this is my answer. This is my equation. And again, I want to note that the difficult part for students on this one is that it's kind of opposite. It's a negative 1. So normally you think negative 1, you think you go to the left. But in this case, we're going to the right, and it's a positive value. Okay, so just write out the formula. Let's go ahead and get the reference points. So the reference points we just did in the intro video. Negative 8, 2. Negative 1, 1, 0, 1, 1, zoom in here, and 8, 2. Okay, and basically what we have to do is just move those points to the right 1 unit. So 1. Oops, that was supposed to be blue. 1 unit, 1 unit, 1 unit, 1 unit. And then now in green, this is my new graph, which we just wrote the equation for above. All right, let's go ahead and try B2. We need to translate it 3 units up. And the question you might want to think about is if you write out the, they call that vertex form. Cube root of b x minus c. Made that one a little bit too long. And some textbooks or websites you'll see don't use C and D, they use H and K. But for our purposes, I'm trying to make it really standard where we've been using transformations of polynomials with A, B, C, and D. And they actually have the same characteristics. Okay, so what is graphing up 3 units? Is it A, B, C, or D? You can look at your chart. It's not A, it's not B, it's not C, so the answer is D. D is equal to positive 3. So I'm just going to translate that in there. Okay? So now I write everything. I don't need the A. I don't need the B. I don't need that parentheses. I don't need the C, so you could just put an X. And I made it too long too. And then plus 3. And here in red, this is our answer. Okay, let's go ahead and graph the reference points. Negative 8, 2 came from the intro video. Negative 1, 1, 0, 0, 1, 1, 8, 2. Okay, and I'm just going to move those points 3 units up. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And there is our cube root. And there is our equation. I love that! B3, let's go ahead and translate the graph to the left 3 units. So again, I have to think about which letter am I going to use? Well, going to the left is a horizontal translation, so that would be the letter C. Okay, pay attention now. If we're going C to the left, that is a negative 3. Okay, so I don't need A, B, and D. And I'm going to go ahead and highlight the C equals negative 3 and put it here. And let's go ahead and write this in. So I have f of x equals the cube root. I don't need the b parentheses, I just need the x. Okay, C was negative 3. Now pay attention, this is the number 1 mistake for students. And I'm going to go ahead and put this in, what color do we have here? Purple. Is the minus sign has to be there. You see that? Don't need a d value. So to clean that up, what's the opposite of negative 3? It is plus 3. So your answer is going to be f of x equals the cube root. You have to have that 3 there always. Plus 3. And this is my answer. Okay, let's get the reference points on there. Remember, these reference points I'm going to highlight come from the intro video, or just think about it. What is the cube root of negative 8? X equals negative 8, that would be negative 2. The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And cube root of 8 is 2. So there's my reference points. And then we basically need to move those, what did we say? 3 units to the left. So let's just count. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And I'm putting in red because my equation was in red. And there's my graph. And that's our answer for B3. All right, B4, that tells us to translate the graph 6 units down. Let's just graph this really quick. I'm going to use reference points. Cube root of -8, x equals negative is 2. Cube root of -1 is -1, 0, 0. Cube root of 1 is 1, and cube root of 8 is 2. And to go down 6 units, I just count down. So look, 1, 2, 3, 4, 5. Let's do that different color, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then this is my graph in red. Okay. Now, how do you write an equation for this one? Well, again, always write out, I always do it, it's super helpful for me, is I like to write out the parent. Okay, question. What is down? Is it an A? No. B? No, that's the horizontal compression dilation. C is moving left and right, so it's just a D value is our winner. Going down 3 units is D equals -6. -6. So I'm going to put that here. Let's go ahead and just write this in. So I have g of x equals the cube root of x, and then that would just be a -6 on the outside of the radical, not on the inside. And what I'm boxing here in red is just what we graphed here on our graph. All right, B5 tells us to compress the graph vertically by a factor of 1/4. So let me write out the parent. Okay, question, what letter is vertical compression? Vertical compression. This is going to be an A value. A value equals 1/4. So I don't need D, C, and B, and then our A value is just 1/4. So f of x equals 1/4 cube root of basically x. And this is our answer. Okay, let's get our reference points. The cube root of -8 is -2. Notice how the x value is kind of what I'm putting in, and then the output or my answer is the y coordinate. -1, -1, 0, 0. Cube root of 1 is 1, and the cube root of 8 is 2. Okay, this is the parent function. Okay, now I want you to think about this. What happens if, we're a company, you're the worker, and I said, oh man, COVID just hit, businesses are being slammed, your wages are cut by 1/4. What does that mean? It's divided by 4. So would your pay go up, like way bigger, or would it go way down? It would go way down. Maybe it's kind of like a video game you play and you can cast a spell onto your opponent, and now their damage that they hit you with is only 1/4 of the damage. Well, the damage is very little. So what's going to happen is our graph is going to get little or compressed. Okay. All right. So let me put let's put the reference points in here. we said negative 8 was negative 2, negative 1 is 1, 0, 0, 1 is 1, and 8 is 2. Okay? So if you go back and look at our intro video, we said that if you ever have to use the table of values, which you can, I'm just trying to show you this. And remember, we only needed the a value, so I don't need this, I don't need that, and I don't need that. So essentially all you need is just x and then a times y. What does this mean? It means that the x values are going to stay the same. That's going to stay the same. What's going to change on there is you're going to multiply a times y. A times this value. So essentially we're going to multiply all these numbers by 1/4. And do my best to get in there. So remember, negative 2 is a fraction, and you just multiply across. So negative 2 times 1 is negative 2. 1 times 4 is 4, so you get negative 2/4. And that is essentially negative 1/2. And 1/4 times 1 is just 1/4. Anything times 0 is 0. 1/4. And we already did above 1/2. Okay? So let's go ahead and get those points on there. So what I'm graphing, let's see if I can get an orange. We haven't used this blue. That's a nice blue. Okay, so I'm graphing negative 8, negative 1/2. So left, negative 8, and then negative 1/2. 1/2 of $1 is like 50 cents, so it's 0.5. You can put that in your calculator, right? 1 divided by 2 is 0.5. So negative 0.5 would be this. And fraction-wise, I mean, this should make sense. Let me see if I can do it in a different color. There's 1, 2, 3, 4. 4 parts, and you only need 1/4 of that. Does that make sense? All right, so let's do the other one. Negative 1, that should be negative 1/4. Yeah, because that was not negative, so negative. So negative 0.25, so it's even like smaller. And then 0, 0, 1, 1/4, so write 1 and then 25 cents. And then 8, 1/2. 8 and then 1/2. So my graph is going to look like this. It almost looks like a straight line, because what's the big idea here? The big idea is that it was what? Compressed. Compressed means pushed down or squeezed. Does that make sense? Or shrink is another word for that. So that was B5. All right, B6, we need to reflect the graph over the y-axis. Let's go ahead and do that. We can do that graphically first. So I'm just going to graph the reference points of a cube root. Negative 8, negative 2. Negative 1, negative 1, 0, 0, 1, 1, and 8, 2. There is the parent in green. Okay, to reflect over the y-axis, the y-axis is this one. So all the points are going to go jump over. Like this point is going to jump over to here. Let's do that in red. Does that make sense? All the points are going to do that. So like this point over here is going to jump all the way over here. It's like the yellow line is a reflection. So another way of thinking about it is if you count 8 here, then you're going to go 8 that way. Okay? So we set a red, right? This way. Whoops. Red, mystery, red. And then, so that was this point, and then this one's jumping the other way. This one's going over here. And then this one is going 8, so it needs to go 8 over there. Okay, so this is my new graph here. Let's use a different color. Let's use, I like that cyan, light blue. Okay, and this is a reflection over the y-axis, the light blue color. Okay, what does that look like for the equation? Well, again, write out that parent graph every time. Hopefully I'm modeling to you guys, just helping you think critically. That's one of the 5 C's of our district. You can look back at what you wrote down for the intro video. The question is, reflection over the y-axis is which letter? Okay, it is not A, because that's a reflection over the x-axis. D is going up and down. C is going left and right, so it is B. And essentially what you have here is your B value is a -1. Or on your notes you had something like B is less than 0. So you're just basically making it negative. That's the big idea. So let's use a different color. -1 goes right there. And I can just write f of x equals the cube root. Okay, here it is, -1. I don't need the parentheses and x minus c. Okay, just have the x right there. And that's it. That's your answer. Let's clean that up a little bit. So this is my answer. Now, again, in English, you wouldn't say I want one iPhone. You would say I want a or an iPhone. So in similar in math, you don't say -1x, you would just write -1. And that's your answer right there. And that's your graph reflection over the y-axis. See you guys. Bye.